So in Chapter 12 we were looking at analysis of variance testing, ANOVA testing, we pretty much rely on computers or calculators to do most of this testing for us. We just interpret the results. No one really does these tests by hand because they're a little bit cumbersome to do the calculations. So our first example is looking at the weights of a certain type of tree, poplar trees, after a month of growth under 4 different conditions. No treatment, special type of fertilizer, or irrigation, or both. And with alpha equals 0.05, we were testing for a difference among the mean weights of the trees after a month of growth with these 4 different treatments. Alright, so the way that we do that is in our ANOVA testing, again testing for a difference among several means. We'll do that with analysis of variance. Now we need to tell the calculator what our data is first. So we'll go into our stat edit menu, stat, and then hit enter on the very first option, edit, so that we can put our information into these lists. Now I've got 4 categories. None, fertilizer, irrigation, and fertilizer plus irrigation, so I'm going to put those into L1, L2, L3, and L4. Alright, so I'm going to clear out L1 first because I had some data from the previous problem in there, from Avery previous problem. You can do that one at a time by hitting delete on those, or you can go up to the list name. Don't hit delete on that list name though, hit clear. If you accidentally hit delete on that list name, it'll clear out that entire list, and you won't be able to use L1 anymore. You have to clear the memory to get it back. That's under second mem. Or the plus sign there, and then reset. It's 7 on most calculators. On the one on the computer here it's number 5. So you go through and reset the memory to get that back if you need to. I haven't found a better way to get that list name back if you accidentally delete it. So if you're up on the list name, have it highlighted. Don't hit delete, hit clear, and that'll clear out the entire list. Alright, so then we can put in our data itself. So 0.15, 0.02, oops, I have to hit enter after each one, otherwise it's going to put them all in the same one. 0.02, 0.16, just go down our first list there, 0.37, 0.22. Okay, and then over to our next list, 1.34, 0.14, oops, 0.14, and you get the idea. So I'm going to pause it and put in the rest here. And by the magic of recording in YouTube, we have all those in there now. So L1, L2, L3, and then L4. We have our 4 lists, each with 5 tree weights in there. All right, and then we wanted to do an analysis of variance test to test for a difference. All right, so we did that on the next page. And again, this is what the table would look like from a computer display, and I gave you a little bit of information as to how to calculate that in the notes. So we want to go to stat, over to tests, check for obvious typos first in your data before you do that, and then down to ANOVA. Now you notice it's all the way down at the bottom, so really when you're from the top you can just hit up and it'll go down to the bottom of the list there. From the top, hit your up arrow and it'll go down to the bottom. Alright, hit enter on that, and it's waiting us to tell us which lists we want to analyze the variation of. So to get those list names in there, we'll hit second and then the number. So hit your second button, and then 1 for L1, L2, second 2, comma, second 3 for L3, comma, above the 7, second 4 for L4. And then close off those parentheses and hit enter. And that'll give us what we need. It gives us the F statistic, our test statistic for ANOVA tests, 5.731 in this case, and our p-value, 0.0073, which we use to make our conclusion. Since that was less than our 0.05 significance level, we could reject our null hypothesis of equal means and say that there is a difference among the means there. Alright, so it's just that easy in the calculator. There's a lot of work that goes into that. The calculator's doing a lot of work behind the scenes there. But stat, edit, enter our data into however many columns we have groups for, and then we go to stat, over to tests, up to the bottom to get to ANOVA, and then we put in our list names there. However many you have, you put in those names of the list that you want to analyze. Alright, and then you just look for that F and the P. The display gives you the rest of the information as well. It gives you the mean square for the factors, the mean square for the errors, the same numbers that we had showing up on our table that I showed you how to calculate by hand show up in the calculator display. But we get to make our conclusion based on that test statistic and the p-value, and that's the first things that it displays for us. Okay, then I'll show you one more with the calculator just to make sure we've got the idea. So I'm going to clear out the calculator there, and we'll go down to this next one. We were looking at chest deceleration in car crashes, vehicle test crashes for cars of different sizes, compact, midsize, and full size. And again, we had 5 of each. There's nothing special about having 5 sample values other than it's a nice, reasonable size for those lists. All right, so we wanted to test the same kind of thing there. Is there a difference in the mean chest deceleration in these different car crashes? Really to kind of get an idea of are these do these different sizes of cars have any difference in terms of their safety? How strong a car collision would be measured in G forces on a chest sensor. We'll do the same type of test here. We're testing for a difference among these means, so that's an ANOVA test. We need to go in and enter our data into those lists. All right, again, to clear those out, you hit clear on the list name, not delete, or you can hit delete individually on each value there. But if you go up to the list name, don't hit delete, hit clear. So I'm going to clear those out, and we'll go ahead and clear out L4 though, even though we're not going to use it. All right, so we had 3 different sizes, so 3 different lists that we want to fill in here. Compact, 57, 47, and so on. We're going across the rows now instead of down the columns. It's however your different treatments are categorized, though. All right, so again, I'll pause it here, pause the recording, and put the rest of those in. Okay, so all of those are in there, and you might notice that one of those values has changed here, because as I was checking that after I entered all the data, I realized that I made a mistake, made a typo the first time around, and that caused a problem with the rest of it. So it was easier to change one of the values than fix the rest of the mistakes in the notes there. So I apologize for that. Obviously, that's not something that we can do with real data, and whoever collected this data, I apologize for fudging your data a little bit to make my notes better, but had to do it. So 5757 instead of 5747 on that second value in the first list there, and then the rest of them were the same. That was just a typo that I made as I was doing that the first time in the notes. We can go through the same process then to do that ANOVA test. Stat over to tests after we've entered all the data into L1, L2, and L3 for our 3 different categories there. Again, going across the rows, becoming our 3 columns for those lists now. ANOVA, and then we want to put in L1. Let me clear that out again so it looks a little nicer. Stat tests up to ANOVA, L1, second 1. You can also use stat and then, no, where is it? List. Second list, second stat, and then the names. On some calculators, I don't think the one on the computer will do it for you, but it'll let you do that on the physical calculators, I believe. And it'll let you choose those list names. But comma and then second, the list name is the easiest way to get to it to me. Second L3. And then we'll close off those parentheses. Actually, you don't have to close off the parentheses. It'll understand and close them for you, but best to keep it the right way. So we get our F statistic, again, now matching the one that we had in the notes, and our p-value, 0.149. Now this time that p-value was greater than our level of significance, 0.05, that we specified in the problem. That's not significant evidence that these means are different. We failed to reject the null hypothesis, and we don't find evidence of a difference among the means, meaning that the chest deceleration on these three sizes of cars is basically the same. And if we found those means, actually, we could go through and do a 1-var stats on each one of those and calculate the mean. 1-var stats L1, for instance, find the mean, and we get 53, and then so on. Do that for the others. We would see that they're probably pretty close together, and that's what's causing us to get this this non-significant p-value here, and causing us not to reject that null hypothesis and not finding a difference among the means. We asked the conclusion of, could we conclude that larger cars are safer? No, we can't, because we're saying that the means are basically the same with our ANOVA test. And even if we did reject the null hypothesis, even if our p-value would have been small enough to reject, then it wouldn't have told us which of those means were different. So keep that in mind. This ANOVA test doesn't give us a terribly strong conclusion. It just says the means are different, or there's not evidence of a difference among those means. It doesn't say which ones are different from the others.